Hello everyone. In this class we will discuss the important MCQs from alternating current. So the question number 1, the value of capacitive reactance is given by. So capacitive reactance, we know that Xc is denoted by Xc and the value is 1 upon omega c. And for inductive reactance the formula is XL is equal to omega L. So the correct answer is X is equal to 1 by omega c. Next question, in DC circuit the inductive reactance of the inductance is. So we know that in the DC circuit the frequency is 0, and with the inductive reactance formula we have XL is equal to omega L. So the frequency is 0, so the inductive reactance is also 0 in this case. So the correct answer is A, 0. Next question, for an AC given by I is equal to I naught 100 cos 200t plus 45 degree into A, what is the value of I RMS current? Okay, so we know that alternating current, the equation of current can be written as I is equal to Im into cos omega t plus 5, or we can write down in terms of sine also. So whatever is here, that is nothing but the peak value of current Im, and we have to find out root mean square value of the current. So the formula of root mean square value of the current is given by Im upon root 2. So from here, if we compare with this equation, the value of Im is 100. So 100 upon root 2. So how to solve 100 by root 2? We don't have to substitute the value of root 2. We have to just multiply and divide by root 2. Rationalization. Okay. So in the denominator, root 2 multiplied by root 2, which is 2. So 100 root 2 upon 2. So 250 is 100. So the answer is 50 root 2 ampere. Next question, a coil of inductance L, resistance R connected to the AC. If the angular frequency of AC source is equal to omega, then the current in the circuit is, okay. So when only L and R is connected, then what is the total resistance? That is given by Z is equal to square root of R square plus, we have XL minus XC square, but C is not there, so only XL square. Okay, so if you write down in terms of omega, so R square plus XL means omega L, so omega square L square. So this is the net resistance. Now the current formula we have I is equal to V upon Z. Z means resistance R. Okay, so V upon Z is impedance when L and R is connected. Okay, so V upon root of R square plus omega square L square. So the correct answer is here D. This is the current. Next question, the angular frequency of AC source used in LCR circuit is decreased. Okay, that means omega is decreased. Then inductive reactance XL and capacitive reactance. Okay, so we have the formula inductive reactance XL is equal to omega L, and XC capacitive reactance is 1 upon omega C. So if omega is decreased, okay, so we know that omega and XL directly proportional. So if omega is decreased, then XL is also decreased, and if omega is decreased in case of here, then this omega and X is inversely related. So if omega is decreased, then X is increased. So the answer of this question, inductive reactance decreased and capacitive reactance increased. So decreased and increased, option number A is the correct answer, not C1. Next, for capacitor at higher frequency, capacitive reactance value is, okay, so the formula of capacitive reactance is 1 upon omega C. If we convert this omega in terms of frequency f, so omega can be written as 2 pi f. So the formula will be 1 upon 2 pi fc. So the capacitive reactance and frequency inversely related. So for capacitor at higher frequency, okay, so the frequency is high, then capacitive reactance is low. So the correct answer is C. Next one, the LCR series circuit resistance offered by L and C is called what? So whenever LCR circuit in series connection is there, the total net resistance offered by the circuit LC, CR or LCR is called impedance. Next one, in LCR series AC circuit equation, impedance represented by, so the impedance formula we have square root of R square plus XL minus XC the whole square. Okay, so the correct answer is A. In RL series AC circuit, impedance value is given by, So if only R and L is connected, okay, then what is the impedance value? So impedance is given by, in LCR circuit, square root of R square plus XL minus XC the whole square. So if it is only R and L are given in series, then XC is not there. Then if we remove the XC, so the answer will be R square plus XL square. Okay, this is the correct answer for this question, not XL minus XC. The next question, for which frequency of AC reactive inductance of 1 Henry inductor will be 1000 ohm. Okay, so inductor is given L value 1 Henry, XL the inductive reactance is given 1000 ohm. So we have to find out at which frequency this value will get. Okay, so the formula we have, XL is equal to 2 pi FL. Okay, main formula is omega L, but we want frequency, so we will convert omega in terms of 2 pi F into L. So we want to find out F, so F is nothing but F is equal to XL upon 2 pi L. So X suffix L, that is given to be resistance, which is 1000 upon 2 pi into L value is nothing but 1. Okay, so we are getting 1000 divided by 2 pi into 1, which is 2 pi. So don't waste your time to calculate this 1000 upon 2 pi. Instead of that, 1 upon 2 pi value you have to remember. So the value of 1 upon 2 pi is nothing but 0.159. Okay, and remaining thing is 1000. Okay, so 1 upon 2 pi value is 0.159. This is very important thing. In the last NEET exam also, one question was there on simple pendulum. So if you know this value, then you can easily calculate without wasting your time. So the value of 1 upon 2 pi is 0.159 multiplied by 1000. So now this multiplication is very easy. 1000 means 30. That means we have to shift this decimal to 3 digits. So the answer is 159 point whatever is there. Okay, so the correct answer is option number C, 159.2 Hertz. The next question is, when 1 microfarad capacitor is connected across V is equal to 100 root 2 sine 100 t volt, current passing through millimeter connected in circuit is. Okay, so from this equation, if we compare this 100 root 2 sine 100 t with our alternating voltage equation, V is equal to Vm sin omega t. Okay, so from here we can say the value of Vm, that is peak value of the current, which is 100 root 2, and omega is nothing but 100 radian per second. We have to find out current, so we have to just simply apply the Ohm's law. I is equal to V by R. Okay, so we have to find out first of all resistance offered by the capacitor. So that formula is nothing but Xc is equal to 1 upon omega C. So 1 upon omega is given to be 100, C is given 1 into micro means 10 raised to minus 6. So 100 means 10 raised to power 2. So 1 upon 10 raised to minus 6 plus 2, which is nothing but minus 4. If we take in the numerator, it becomes 10 raised to plus 4. So that is the value of Xc. Now if you apply the formula, I is equal to V upon that our Xc. So V is given to be 100 root 2. Okay, this is the peak value of the voltage. So if we apply that 100 root 2 divided by 10 raised to minus 4, 10 raised to plus 4, then 100 means 10 raised to 2 into root 2 as it is. If we take 10 raised to 4 in the numerator, it becomes 10 raised to minus 4. So the answer will be root 2 into 10 raised to plus 2 minus 4 will become minus 2. Okay, but this is the value of peak value of the current. We have to find out RMS value of the current that actual emitter can read. Okay, so we have to divide by root 2. So 10 raised to minus 2 upon root 2. Here also root 2 is there. So root 2 and root 2 will get cancelled. So the RMS value of the current is 10 raised to minus 2. But we want answer in millimeter. Okay, so if we multiply 10, Now need to multiply 10 raised to minus 2. If you want to write down in millimeter, we can write down as 10 millimeter. Okay, ampere. So if you solve this, 10 into milli means 10 raised to minus 3, you will get again 10 raised to minus 2. Otherwise, no need to solve that full thing because we are getting 1 as a digit. So in only one option we have the digit as 1. So the correct answer is 10. Okay, so 10 milliampere. Okay, if you solve, you will get nothing but 10 raised to minus 2 ampere only. Look at the next question. 20 ohm resistance is connected to V is equal to 220 sine 100 pi t voltage source. Time taken by current to reduce from maximum value to its RMS value is. Okay. So V is equal to given 220 sine 100 pi t. Now if you see in this question only resistance is connected. So when in the circuit only resistance is connected, then voltage and current are both in the same phase. That means if you want to write down the equation of current, so we can write down as I is equal to I naught sine, this will be the same thing 100 pi t, because there is no change in voltage and current, they are in the same phase. Now we have to find out the time taken by current to reduce from maximum value to its RMS value. Okay, so if we convert this I into RMS, so I RMS is equal to I naught sine 100 pi t. So the formula of I RMS value is nothing but I naught upon root 2 is equal to I naught sine 100 pi t. So if we cancel out I naught, then we will get 1 by root 2 is equal to sine 100 pi t. So sine, at what angle sine gives you 1 by root 2? 1 by root 2 means nothing but sine 45 degree, means pi by 4. So if we compare this two sides, we will get pi by 4 is equal to 100 pi t. So we have to find out the time t. So this 100 and pi will go in the denominator. So pi upon 4 into 100 pi. So pi and pi will get cancelled. 4 into 100, which is 400. So 1 by 400. Or you can write down 4 into 10 raised to 2. 1 by 4 is nothing but 0.25. And if you take this 10 raised to 2 in the numerator, it will become 10 raised to minus 2. So the correct answer is, okay, if you take this one decimal point to the right side, we will get 2.5 into 10 raised to minus 3 second. So the correct answer is D, 2.5 into 10 raised to minus 3 second. Look at the next question. Two graphs are given. We have to identify which graphs shows capacitor and inductor reactance. So look at this graph. Here on the y-axis reactance is given, and on the x-axis frequency is given. So graph is decreasing. So we know that the formula of inductive reactance XL is equal to omega L, and for XC is equal to 1 by omega C. So in case of capacitive reactance, omega and XC are inversely related. So in this case graph is decreasing. So this first graph, frequency versus reactance, is nothing but for capacitor. And for second graph, if you see, frequency increases. With increase in frequency, reactance is also increasing. So in this case it is nothing but inductor, because in inductor frequency and reactance are directly proportional. So this second graph shows the inductive reactance. So the correct answer is first graph capacitor, second graph for inductor. Look at the next one. Next question is very simple. A coil having inductance of 1 millihenry connected to AC source. In inductive reactance obtained 1 ohm. So XL is given 1 ohm. L is given 1 millihenry. So we have to find out angular frequency omega. So the formula we have, XL is equal to omega L. Omega we have to find out. So XL upon L. XL is 1. L is given 10 raised to minus 3 because it is milli. So 10 raised to minus 3. If we take 10 raised to minus 3 in the numerator, it becomes 10 raised to plus 3 radian per second. The correct answer is A. Look at the next one. The question is, in AC circuit, frequency 400 upon pi Hz. Okay, so F is given 400 upon pi. Reactance of capacitance XC is given 25 ohm. we have to find out the value of C. So the formula of xc is equal to, we have 1 upon omega c, but frequency is given, so we will convert in terms of f. So it will become 1 upon 2 pi fc. So we have to find out this c. So if we change this, if we take this c here, so c is equal to 1 upon 2 pi f into xc. Okay. So if we substitute the values, 1 upon 2 pi into f value is given 400 upon pi into xc, that is given 25. So this pi and pi will get cancelled. 25 to the 50. So 1 upon 50 into 400. So 4 5s are 20, so it will become nothing but 1 upon 20 and remaining 3 zeros. So 1 by 2 means nothing but 0.5, and the remaining 4 0, that means 10 raised to 4. If we take in the numerator, it will become 10 raised to minus 4. Okay. So if we take this point into two digits to the right, so we'll get 50 multiplied by 10 raised to minus 6, and 10 raised to minus 6 is nothing but micro. So the correct answer is 50 microfarad. Otherwise, in only one option the digit is 5 is there, so you can correct the answer from that digit only. Look at the next one. In LCR circuit, R, XL, XC, all these three values are given. The value of impedance is, so the formula for impedance is root of R square plus XL minus XC the whole square. So R is given to be root 7, so square of root 7, which is 7. Then XL minus XC, so 11 minus 8, which is nothing but 3, and 3 square is nothing but 9. So 7 plus 9, which is 16, and root of 16 is 4 ohm. So the correct answer is A. Look at the next question. An alternating voltage V is equal to given to be 400 sine 500 omega t connected to 0.2 kilo ohm resistor. What is the value of RMS value of current? Okay, so IRMS, if you write in terms of voltage, the formula will be VRMS upon root 2. Okay, so from this equation, this 400, that is nothing but peak value of the voltage. So if we convert this VRMS formula is nothing but V0 upon root 2. Sorry, here formula is IRMS is equal to VRMS upon V by R, simple Ohm's law, VRMS upon R. And the formula of VRMS is nothing but V0 by root 2 and R as it is. Okay, so R is given 0.2 kilo ohm. So if we convert 0.2 kilo means 10 to the power 3. So 10 raised to 3 means 1000. So if we multiply with 0.2, that means 3 digit we have to shift. Okay, so 0. Let's write 1, 2, 3, 10 raised to 3. Okay, so 1, 2 and 3, that means the value is 200 ohm. Now if we substitute the values, V0 is nothing but peak value of voltage, which is nothing but 400 divided by root 2, and R is nothing but 200. So this 200, 2s are 400, so we are getting 2 upon root 2. To solve this, let's rationalize. So root 2 divided by root 2, if we multiply, so root 2 into root 2 in the denominator, which is 2, so 2 upon 2 into root 2. So this 2 and 2 will get cancelled, so answer is root 2, and the value of root 2 is nothing but 1.41. Okay, remember this value, root 2 value is 1.41. So correct answer is B. Look at the next question. When 50 watt bulb is connected with 220 volt bulb, magnitude of RMS current flowing in the bulb will be. So we have to find out RMS current. So the formula we have, IRMS is equal to VRMS upon R. So resistance is not given, so we have to find out resistance first. So formula P is equal to, we have V square upon R. So R, if we take here, so R is equal to V square upon P. So V is given to be 220, so 220 multiplied by 220 upon power is 50. Okay, so if we cancel out 220 into 220 upon 50, so 0 and 0 will get cancelled. So if we multiply and if we divide by 5, we'll get 968 ohm. Now to find out RMS value, so VRMS, which is nothing but 220 upon R is 968. So if we cancel out by 4 this, so we'll get 55 forza, and this will be 242 forza. Okay, now no need to divide this full thing. you have to just see 55 and 242. Okay, so we'll take a point and 10 here. So which is the first digit? Okay, no, we don't have to solve this full thing. If you look at the option after the decimal, the first option is 1, here it is 2, here it is 3, here it is 4. So which digit will come, that is the important, only that you have to see. Okay, so 242 into 2, if you do, we will get 484, which is nearby this. That means the first digit is 2. So our correct answer is B. Okay, no need to solve anything else. Look at the next one. So this is a theory based question. RMS value is same as how much percent of IM value, maximum peak value of current. So the formula we have, IRMS is equal to peak value of the current upon root 2. Okay, so if we solve this 1 by root 2, 1 by root 2 is nothing but 0.7071 times IM, which is nothing but we can write down in terms of percentage, approx 70.71% of peak value. Okay, so remember this, the number. Look at the next one. Inductive reactance of inductor for 50 Hz frequency. So F is given is 10 ohm. Okay, so XL value is given. If for 200 Hz frequency, the reactance will be what? Okay, that is the question. So if you apply the formula, we have XL is equal to omega L. Omega is nothing but 2 pi FL. So XL is given to be 10 ohm whenever the frequency is 50. Okay, so if you find out the value of L from here, so L is equal to 10 upon 2 pi 50. So this 10 pi is a 50, so we'll get 1 upon 5 to the 10 pi. So the value of L is 1 upon 10 pi. Now the question is, what is the value of XL when the frequency is 200? So we'll apply the formula again, 2 pi FL. So in this guy, 2 pi as it is, frequency is 200 and the value of L is 1 upon 10 pi. So this pi and pi will get cancelled. This 110 if you cancel out, so the answer is 2 into 2, 4 and 10. So the answer is 40 ohm. Option number B. Next question. Capacitive reactance of capacitor is X. If capacitance value and frequency both are doubled, then the new reactance will be. Okay, so the formula we have, XC is equal to 1 upon omega C. Okay, so if we convert in terms of 2 pi F, so 2 pi FC. Now what is doubled? Capacitance value and frequency both are doubled. Okay, so the new capacitance, let's say XC dash 1 upon 2 pi is a constant as it is. Frequency we have doubled, so F become 2F. Capacitance also doubled, so C become 2C. Okay, so the new extra number is 2 to the 4, which is in the denominator. So 1 upon 4 times 2 pi FC. So 1 upon 2 pi FC is nothing but original capacitive reactance. So 1 by 4 times XC. So the new capacitive reactance is 1 by 4th of the original. That means X by 4. So correct answer is C. Look at the next one. A pure capacitor of capacitive reactance 10 ohm. So XC is given 10 ohm. Resistance when capacitor is connected. If the frequency of the source is doubled, then the capacitive reactance will be. So we know that capacitive reactance and frequency inversely related. So frequency is doubled. Okay. So if F is doubled, that means 2F. Then capacitive reactance become, let's say new capacitance become half. Okay. So original capacitance reactance is 10 ohm. So the new capacitive reactance is nothing but 10 upon 2, which is nothing but 5 ohm. Because capacitive reactance and frequency inversely related, so frequency is doubled, then capacitive reactance will be halved. So original is 10, so half will be 5 ohm. So correct answer is 5 here. Look at the next question. With resistance of pi into root 3 ohm, inductor of the value should be connected in series so that 50 Hz frequency and phase difference between the voltage and current is 30 degree. So we have to find out the value of L, for which resistance is pi root 3 frequency is 50 Hz and the phase difference angle is 30 degree. Okay, so the formula of phase difference in terms of inductor we have tan phi is equal to XL upon R. So XL formula is nothing but 2 pi FL upon R. Okay, so tan phi is nothing but phase difference between voltage and current, which is given to be 30 degree. So tan 30 value is 1 upon root 3. 2 into pi, F means frequency, which is given 50, L we have to find out, resistance is given root 3 pi. So this pi and pi will get cancelled, and from both the side root 3 will get cancelled. 2 into 50, which is 100. Okay, so 1 is equal to 100 L. So this 100 will go in the denominator, so L is equal to 1 by 100, which is nothing but 10 raised to minus 2 in the numerator. So 10 raised to minus 2 is nothing but 0.01 Henry. So the correct answer is D, 0.01. Look at the next question. LCR series AC circuit supplied with 12 volt 50 Hz frequency. Supply current flowing in the circuit is 0.5 ampere. If phase difference between voltage and current is pi by 3 radian, then find the value of the R. Okay, so current is given 0.5 ampere. So if you apply the formula, IRMS is equal to VRMS upon Z. So from here Z is nothing but VRMS upon IRMS. So voltage is given 12, current is given 0.5. So 12, 0.5 means nothing but 1 upon 2. So this 2 will go in the numerator. So 12 to the 24 ohm. Okay, so this is the value of Z, 24 ohm. Then phase difference is given pi by 3. So if you apply the formula, tan phi is equal to XL upon R. So we are using here XL upon R because here it is given that difference between voltage and current is pi by 3. So that means voltage is leading here as current by pi by 3. So it is nothing but inductor circuit connected with inductor. So tan phi is equal to XL upon R, and so phi is given pi by 3. So tan pi by 3 is equal to XL by R. So tan pi by 3 value is nothing but 1 by root 3 is equal to XL by R. So if you multiply cross, so XL is equal to root 3, tan pi by 3, which value is nothing but pi by 3 means 60 degree. So tan 60 is root 3. So if you multiply in a cross, we will get XL is equal to root 3 R. So we will apply impedance formula. Z is equal to root of R square plus XL the whole square, since X is not there. So R square plus XL value is nothing but root 3 R and the whole square. So R square plus root 3 square is 3 R square. So R square plus root 3 R square plus 3 R square, which is root 4 R square. So the value of root 4 is nothing but 2, and value of root R square, which is R. So we are getting Z is equal to 2R. And the value of Z in the starting we got 24 ohm. So 24 is equal to 2R. So if we take 2 in the denominator, so R value is nothing but 12 ohm. So the correct answer is 12 here. So the important catch here for this question is nothing but this keyword. Phase difference between voltage and current is given pi by 3. So voltage and current phase difference pi by 3 is given. That means voltage is leading by current by pi by 3. Okay, that means it is nothing but RL circuit. That's why we have used here the formula tan phi is equal to XL upon R. Okay, look at the next question. 50 microfarad capacitor is connected with 220 volt supply with 50 radian per second supply. RMS value of the current will be. Okay, so the formula of IRMS is equal to nothing but VRMS upon resistance. In this case, resistance is nothing but XC because capacitor is connected. So VRMS upon XC. So XC formula is 1 upon omega C. So denominator of the denominator will go in the numerator. So VRMS multiplied by omega times C. Okay. IRMS is equal to. So the value of VRMS, which is 220, omega, which is given to be 50 radian per second, and capacitance value is given 50 microfarad. So that means 10 raised to minus 6. So if we multiply this 22 into 5 into 5, we'll get some number. And if we solve the 0, 10 raised to minus 6, here it is 1, here it is 1, here it is 1. So 3 zeros we have to add up. So it becomes 10 raised to minus 3. Okay. And if you multiply this 22 5 into 5, then we'll get 550 into 10 raised to minus 3. So if you want to remove this 10 raised to minus 3, then we have to take this decimal 3 digit to the left. So 1, 2 and 3. So 0.55 ampere. So the correct answer is C, 0.55 ampere. Look at the next one. Look at the next one. This circuit diagram is given, which is connected by resistance R and C. So we know that in resistance case, current and voltage both are in the same phase. And in case of capacitor, current leads by voltage. So current is leading by voltage with pi by 2. Okay, so if you look at the option, in option number D, current is here and voltage is here in this case of resistance. So this is wrong because current and voltage in the same phase in case of resistance. Similarly here, current and voltage in case of resistance is not in the same phase, so B is wrong. In the option number A and C, current and voltage are in the same phase in case of resistance. Then when we connect the capacitor, current leads the voltage by pi by 2. So current is leading by voltage pi by 2. So option number A is the correct answer. Similarly, the next question in that LC circuit is there. So we know that in capacitor, current leads by voltage. So if you look at the option number D, current is leading by the voltage pi by 2. In case of inductor, voltage leads current by pi by 2. So that is also correct. So option number D is the correct answer here. Look at the next question. In a given circuit, V is equal to 5 volt, VL is equal to 3 volt, then what is the value of VR? Okay. So the net potential, the formula we have, V square is equal to voltage across resistance square plus voltage across inductor square. So V is given 5, so 5 square is equal to VR, we have to find out. VL is given to be 3, so 3 square. So 5 square is 25 and 3 square is 9. So if you take this 9 this side, so 25 minus 9 is equal to VR square. It is to be 16 is equal to VR square. So if we take the square this side, root of 16, it becomes nothing but 4. So the correct answer is 4 volt. Look at the next one. Next question. In AC circuit with only capacitor. Okay, so in case of only capacitor, the voltage is lagging by the current pi by 2. Okay, so correct answer is C, voltage is lagging in current by pi by 2, because in capacitor circuit, current leads by the voltage by pi by 2. Next question. At what angular frequency of source, current in the series LCR AC would become maximum? So we have one condition that is called resonance frequency. So the formula of resonance frequency is nothing but omega is equal to 1 upon root of LC. So when the frequency is at resonance, the current is maximum. So the correct answer for this question is B. At resonance frequency, current is maximum and resistance is minimum. And the condition is XL is equal to XC at resonance. Look at the next question. When resonance takes place in LCR circuit, then out of 4 options we have to select. The question options are along phase difference. So the formula in LCR circuit phase difference is tan phi is equal to XL minus XC upon R. But in case of resonance, XL is same as XC. So this XL is equal to XC, the difference between 0. Okay, so 0 by R, which is 0. So at what angle tan is 0? At 0 degree only. So the correct answer is phase difference between current and voltage is 0 degree. Look at the next one. Look at this next question. This is a nice question. This diagram is given. So the question is, for resonance in above circuit, angular frequency omega and amplitude of current are respectively. Okay. So in case of resonance, the formula of angular frequency is 1 upon root of LC. So 1 upon square root of L value is given 8 millihenry. So 8 into 10 raised to minus 3 multiplied by C value is given 20 microfarad, that means 20 into 10 raised to minus 6. So if you solve this, 8 multiplied by 2, okay, just a number, 8 into 2 which is 16, so root of 16, then multiply by 10 to the power. Now just add the power, so here it is minus 3, here it is minus 6 which is minus 9, and one more 0 is there here that we have not counted, so that power we have to add up. So minus 3 minus 6 which is minus 9, minus 9 plus 1, so it is minus 8. So root of 16 which is nothing but 4, and square root of 10 raised to minus 8. Okay, so 10 raised to minus 8 can be written as minus 4 whole raised to power 2. So square root of 10 raised to minus 4 whole raised to power 2, which is nothing but 10 raised to minus 4. Okay, so if we take this 10 raised to minus 4 in the numerator, we will get 10 raised to plus 4, that means 10,000 divided by 4. So 10,000 upon 4, which is nothing but 2,500. So angular frequency is nothing but 2,500, so D option is wrong. Remaining all option has angular frequency 2,500. Now the second thing is we have to find out the current. Okay, so the important thing is here we have to find out the current at resonance. So in case of resonance, we have Z is equal to R, the impedance is same as resistance R, and the current is maximum here. So we have to find out the value of peak current I0. So the formula is V0 upon R. Okay, so what is the formula of peak current V0? We have the formula Vrms is equal to V0 upon root 2. So the V0 value is nothing but Vrms multiplied by 2. So Vrms multiplied by root 2 upon the resistance value. Okay, because at the resonance the value of the impedance is same as R. So if we substitute the value Vrms, which is nothing but given to be 220, so 220 multiplied by root 2 upon the R value. So resistance is nothing but 44 ohm. So 44 divided by 44. So 22 2s are 44. So in the numerator 10 root 2 upon 2 is remaining. So 2 5s are 10. So answer is 5 root 2. So the current is 5 root 2 ampere, which is correct answer is A. Okay, so don't make the mistake. This is the resonance. In case of resonance, current is maximum, so we have to find out the peak value of the current by using this V0 by R. Look at the next question. The next question is in LCR circuit, by changing dash, the resonance frequency of the circuit change. So we know that the formula of resonance frequency omega is equal to 1 upon root LC. So resonance frequencies depend on L and C value. So if we change L and C value, then the frequency will change. So correct answer is D. Next question, in LCR AC circuit, at resonance IRMS value. So IRMS formula we have Vrms upon R. If we apply the formula of Vrms, which is nothing but Vm or Vmax upon root 2 R as it is, so the formula is Vm upon root 2 times R. So correct answer is B. Look at the next one. This is theory based question. To increase the sharpness of resonance curve, value of dash should be decreased. So if we decrease the resistance value, because at resonance we know that Z is equal to R, so resistance is minimum, current is maximum. So to increase the sharpness of the resonance curve, if we decrease the value of R, okay, then the curve is sharp. Next question, in LCR circuit at resonance. Okay, so at resonance, imaginary part of the impedance is 0, correct. Current and voltage are in the same phase, power factor is 1. Okay, so all the options are correct in this case. At resonance, these are the conditions. Look at the next one. Resonance frequency LCR AC circuit series F0 is. Okay, so the formula we have omega is equal to 1 upon the root of LC. But omega is nothing but we can write down as 2 pi F0 upon root LC. So we have to find out F frequency. So F is equal to 1 upon 2 pi square root of LC. So whenever the question will come to find out the frequency, remember the value of 1 upon 2 pi, which is nothing but 0.159 to solve the question easily. So the correct answer for this question is A, 1 upon 2 pi root LC. Next question. A 10 ohm resistance, 5 millihenry inductor and 10 microfarad capacitor are joined in series. When a suitable frequency of alternating current source is joined to combination, the circuit resonates. If the resistance is halved, the resonance frequency. So the correct answer is remain unchanged, because resonance frequency formula we have omega is equal to 1 upon root of LC. So resonance frequencies totally depend on L and C. Okay, and in this case the question is saying resistance is half. Okay, R. The new resistance is R by 2. But resonance frequency is independent of resistance. There is no use of resistance. Okay, so the resonance frequency will remain unchanged. Look at the next one. The next question is LCR series circuit is applied to AC voltage. In which of the following current flowing in the circuit will become maximum? So we know that current become maximum at resonance condition. So at resonance we have the condition XL is equal to XC. So XL means omega L, XC means 1 upon omega C. So if we do the cross multiplication, we will get omega L into omega C is equal to 1. So omega into omega, omega square into L into C. If we take this one this side, become minus 1 is equal to 0. So the condition is omega square LC minus 1 is equal to 0. So correct answer is C. Look at the next one. Next question, in LCR series circuit, C value is given 10 microfarad, omega is given 1000 radian per second. For which value of inductance, means L, current obtained will be maximum? Okay, so current is maximum, that means we have to apply resonance frequency formula. At that frequency only current is maximum. So formula we have omega is equal to 1 upon square root of LC. So we have to find out this L value. To find out this L, we have to remove this square root. Okay, so we will do the square on both the side. So square of omega is equal to this side also 1 upon root LC the whole square. So we will get omega square is equal to 1 square is 1 upon square root of LC the whole square, which is nothing but LC. So to find out L, we will write L is equal to 1 upon omega square into C. So 1 divided by omega, omega is given 1000. So 1000 means 10 raised to 3 the whole square into C value is given 10 microfarad. So 10 micro means 10 raised to minus 6. So 10 raised to 3 raised to power 2, which is nothing but 10 raised to 6 into 10 into 10 raised to minus 6. So 6 minus 6, that is 0. So 10 raised to 0 is 1. So only this 10 will remain. So 1 upon 10. 1 upon 10 means nothing but, if we take in the numerator, it becomes 10 raised to minus 1. Okay. Look at the option. First is 1 millihenry. 1 milli means 1 into 10 raised to minus 3. But we are getting 10 raised to minus 1. So first is wrong. C option, 100 millihenry. So 100 means 10 raised to 2. Milli means 10 raised to minus 3. So if we solve the power, we'll get 10 raised to 2 minus 3, which is minus 1. So this is the correct answer, because we are getting also 10 raised to minus 1. Look at the next one. In AC circuit, inductance 50 millihenry with negligible resistance, capacitor is given 500 picofarad. The resonance frequency of the given circuit is, okay, resonance frequency F we have to find out. So we have the formula F is equal to 1 upon 2 pi root LC. So if we substitute the values, 1 upon 2 pi square root of L is given 50 milli, so 50 into 10 raised to minus 3 into C is given 500, pico means 10 raised to minus 12. So let's solve the power first. So this 1 upon 2 pi as it is, square root of this 5 into 5, which is 25, multiply by 10 to the power, here minus 3, here minus 12. So if we add up minus 3, minus 12, minus 15, and one more 0 is here, 1, 2 and 3. So minus 15 and plus 3 zeros, that means again minus 12. So 10 raised to minus 12. So 1 upon 2 pi as it is, root of 25, which is nothing but 5, and root of 10 raised to minus 12. So 10 raised to minus 12 is nothing but 10 raised to minus 6 the whole square. So root of 10 raised to minus 6 the whole square, which is 10 raised to minus 6. So if you multiply 5 into 2, which is nothing but 10, so 1 upon 10 pi into 10 raised to minus 6. So again if we add the power of 10, so we'll get 1 upon pi. So minus 6 plus 1, which is minus 5. If we take in the numerator, so it becomes 10 raised to plus 5. So 10 raised to 5 upon pi hertz. So option number A is the correct answer. Look at the next one. Next question is for one series AC circuit. Its reactance. Reactance means XL minus XC is equal to its resistance. That means is equal to R. Then its power factor is, okay. So power factor formula is given by tan phi is equal to, phase difference formula if you apply, tan phi is equal to XL minus XC upon R. Okay. XL minus XC upon R, tan phi is equal to. But it is given that XL minus XC is same as R. So we substitute here, so we will get R upon R, which is equal to 1. So we are getting tan phi is equal to 1. So at what angle tan value is 1? The angle is nothing but 45 degree, which is pi by 4. So we have to find out power factor. So the formula of power factor is cos phi, and phi value is nothing but 45 degree. So cos 45 is 1 upon root 2. So the correct answer is C, 1 upon root 2. Move to the next question. Wattless current is possible in the circuit having. So wattless current means in that case power is 0. So we know that when we connect inductor or capacitor only, in that case power is 0. So wattless current we will get in terms of only L and C circuit. Look at the next one. Look at the next question. In AC circuit, voltage and current are represented by V is equal to 100 sin 100t, I is equal to 100 sin 100t. So if you see the equation properly, there is no change in the phase difference. Here also sin 100t, here also sin 100t. So both current and voltage are in the same direction. That means it is nothing but circuit containing connected with resistance R only. So then power in the circuit is, so power formula we have average power IRMS into VRMS into cos phi. Okay, so if you apply the formula, IRMS is nothing but I naught upon root 2, VRMS is V naught upon root 2, and cos phi is both current and voltage are in the same direction, so phi is 0 degree here. So I naught, which is nothing but 100, V naught, that is also 100. So 100 multiplied by 100 upon root 2 into root 2, which is 2, and cos 0 is 1. Okay, so 100 into 100, which is nothing but 1, 2, 3, 4, 0 upon 2. So if we cancel out, 2 5s are 10 and remaining 3 zeros. So the answer is 5000. Okay, here current is given, if you see properly, current is given here in a milliampere. So that means I naught is given milli. So multiply by, we have to do 10 raised to minus 3. So this 30 and this 30 will get cancelled. So correct answer is not 5000, it is 5. Okay, so current is given in a milli. So don't make the mistake in the exam. Look at the next one. Next question, in LCR circuit, when power factor is maximum, then what is the condition? So it is straightforward result. Power factor is maximum whenever XL is equal to XC, or you can say whenever Z is equal to R, means in case of resonance. Okay. Otherwise this is the proof, you can go through it. So the correct answer is A, XL is equal to XC. In that case power factor is maximum. Look at the next one. Next question, if NP and NS are the number of turns in primary and secondary coil, then for step up transformer. So we know that step up transformer means number of coils, number of turns in the secondary coil is more as compared to number of primary. So NS is greater than NP in the case of step up. In step down transformer, number of primary coil is more instead of number of secondary in step down. So the correct answer is A. Secondary coil has more number of turns in step up transformer. Look at the next one. Step up transformer has transformation ratio 3:2. What is the voltage in secondary if the voltage in primary is 30 volt? Okay, so transformer ratio is given 3/2, which is nothing but step up transformer. So it is step up means the secondary coil has more number of turns, so it is N2 upon N1 is given 3/2. Okay, this ratio is very important. So N2 by N1 is given 3/2. We have to find out the voltage in secondary. Okay, so number of turns and voltage are directly relation in the transformer ratio. So if you apply the formula N2 by N1, which is same as Vs by Vp. So N2 by N1 is given 3 by 2. We have to find out voltage in secondary. Voltage in primary is given to be 30. So if we do the cross multiplication, so 3 into 30 upon 2, if we cancel out 15 to the 30, so 15 is a 45. The correct answer is 45 volt in the secondary voltage. Look at the next one. The next question is, a step-up transformer operates on 230 volt line, supplies 2 ampere to a load. So 2 ampere to a load means this is nothing but current in secondary. The ratio of the primary and secondary winding is 1:25. That means N1 upon N2 is given 1:25. So the current in primary, we have to find out current in primary. Okay. So we know that the current and number of turns are inversely related. I is proportional to 1 by N. So if you apply the formula IP upon IS, which is nothing but NS upon NP. Okay. So ratio is given NP upon NS is given 1 by 25. So if we apply here, it becomes 25 by 1. We have to find out current in primary, current in secondary is given 2. So if we do the cross multiplication, so IP is nothing but 25 to the 50 ampere. So the correct answer is 50A. Next question, for a step-up transformer, value of transformation ratio is. So we know that in the step-up transformer, number of turns in the secondary coil which is greater than number of turns in primary coil. So if we divide by both the side by number of turns in primary, so NS upon NP is greater than NP upon NP. Okay, so NP upon NP, which is nothing but 1, and this NS upon NP, which is called R, that is called transformation ratio R. So R must be greater than 1 in case of step-up transformer. So correct answer is A, R must be greater than 1. Look at the next one.